Hi, my name is Trey Hayden, and in today's video I want to cover how you might go about emitting some sort of particle effect or other visual at a given location. And a kind of canonical example for this might be you have some sort of very simple top-down shooter like this one where you have some bullet and ideally we would like for whenever one of these little rectangles hits a wall to just emit some sort of very basic flash to just notify, hey, I hit the wall, I'm not traveling anymore, I haven't gone through something. Just some sort of visual feedback for the player that everything seems to be working correctly. And I see a lot of solutions for this problem involving multiple particle systems and pooling and that kind of stuff, which is all fine. Those all have their place. But for this particular situation, I think there's a much cleaner way of going about this using scriptable objects and a single particle system that's shared between impacts. And so this video will go into sort of how we would go about implementing that, some of the pros and cons of this approach, and sort of introduce you to the notion of scriptable object events, or scriptable objects as an event system, sort of as a baseline, that if you wanted to continue using a system like this in the future projects, it wouldn't be too much of a stretch. Okay, so before we do anything interesting, let's go ahead and just see what this would look like if we implemented it in a pretty basic and almost naive way, where we're going to go to the bullet prefab, and what we're going to do here is basically add a new prefab reference to here, so that whenever the bullet hits the wall, we're just going to instantiate that other prefab at that point. So let's go into the player bullet code. There's not a whole lot going on here, but we're going to scroll down here to the collision code. And we're going to add a new functionality here. So let's make a new inspector variable, impact prefab. And we're going to assign our particle system here. And down here, let's say collision2d.contact count. If that's bigger than 0, and I actually have an impact prefab to play with. And what we're going to do here is get the first contact point we have, get contact 0, and we're going to just create the prefab here. Instantiate impact prefab, first contact at point, quaternion.identity. So this should be more than fine for a very basic approach to this problem. And so we're going to go up to here. We already have this prefab for the wall impact. Let's go ahead and drag that in. And let's go back out to here. So if we run this and we shoot the wall, then sure enough, the prefab is being created there and the particles do play. So if this was like a game jam or some 48-hour project that you just need to get stuff done in as short amount of time as possible, realistically, you're probably done, right? This isn't the world's biggest concern, but personally, this has always kind of bugged me. And when I see folks discuss this problem in videos and stuff, they solve this with pooling, where you essentially create a bunch of particle systems ahead of time, you get one, and then the impact uses a pooled system, and that's kind of that, right? And I don't like this approach, to be honest, because I feel like that's the same sort of thing where we're still devoting a lot of memory and a lot of just hierarchy space in general to essentially a very basic problem, which is emit the same particle system and the same particle effect at different locations. And so I don't agree that the solution should always be to pool visuals. In my projects, I do have situations where visuals are pooled, but for this situation, I don't think that's how, I don't agree with that being the de facto community solution. And so we're going to go over a different way of implementing this now, where rather than having multiple systems emitting the same basic particle effect, we're going to have a single particle system emitting that effect that is notified by the bullet itself. So if you haven't used this kind of scriptable object approach before, it'll seem a little bit foreign. And when I mentioned that, like in this case, we want the bullet to sort of be notifying some sort of external system that, we might be doing something like, let's just say, bullet impact singleton or whatever, emit at, and again, this doesn't exist, but just pretend we're doing this first contact point, that we would be doing something like this, where there's some singleton and it's going to handle all of this kind of clunkiness for us. And the syntax will still look like this, but we're not going to do this with singletons. And what we're going to do instead is a project level asset in the form of a scriptable object that will kind of act as a relay between this bullet and whatever system needs to observe this kind of event. So let's go ahead and start implementing the guts for that, and then we'll slowly kind of see this take form. I'm gonna make a new folder within this sort of project folder, scriptable objects, plural preferably. All right, and in here, what I'm going to do is particle event. So this is where it might look a little odd if you haven't seen this kind of stuff before. Unity engine. Okay, so rather than mono behavior, what I'm going to do is public class particle system, or particle event, excuse me. And it's going to inherit from scriptable object. And what we're going to do here is create asset menu, menu name, data, events, particle event, file name, new particle event. Okay. So what we'd like to do for this is have basically a pair of objects. The first object in the pair is going to be this thing, this particle event, which is going to be, again, some scriptable object that exists in the project level. And the other one, the one that's actually listening to this thing, is going to be on an object within the project itself, within some sort of something in the hierarchy. So let's do that one now. Particle event listener, CS. And this is going to be more traditional for what folks are probably familiar with. It's going to be Unity engine, mono behavior, the same kind of stuff we normally write code for. Public class particle event listener. It's going to be mono behavior. And we need a few things here. The first one is some sort of function that would be called when the event is actually raised. So on raised, vector 3 position, some sort of place in the world that we care about. We'll deal with implementation later. And this is all we can kind of do for now, because we want to register this thing, but we don't have anything to register it to in the particle event yet, so let's do that. Go back over to here. We're going to keep some sort of list of the listeners that we know about in the project. So private list particle event listener, listeners, so new. And now we can sort of start going about registering these things. So void on enable. Oops, I need a reference to my particle system that we're actually listening to. That's actually super important. Our particle event. This dot particle event. Register this. And same thing, we're going to unregister on disable. I like enable and disable for this because these are kind of guaranteed to always be called. Start, you're not guaranteed. Awake is not guaranteed. Those mean the object has to be sort of enabled. Maybe not start. I don't remember how start works actually, but I only ever really use awake, and I honestly use start if I need something a little bit after awake. But on enable and on disable, like these are pretty sure. You're pretty sure these are going to get called. If the object is around or not around. And this matters because, again, this is particle eventing is at the project level. So we don't want lingering references to things that may or may not exist in the scene. So if at any time this thing is destroyed or disabled, we just want to remove its reference entirely. That's what we're going to do. So public register, event listener, add. And then same thing for unregister, right? So this should be happy, this is happy, so everything's happy right now. So let's go ahead and actually start raising this thing. So public void raise, vector 3 position. And we're gonna just iterate through our listeners in kind of a naive way. This listeners.count. Plus listener, listeners. I don't like doing for each for this because if you have some sort of event where you maybe subscribe a new event or something else gets enabled, then this will break. So make sure this listener actually exists. Raised position. Okay, so this by itself should be done. let's go back over to the listener, and we're actually implementing this thing. This is where it can deviate a little bit depending on how you actually want to go about it. I usually, honest to God, do this with Unity events, where there's just some sort of block of stuff in the inspector that you can sort of dynamically sort of drag and drop in there by itself. I prefer that approach, honestly. But it requires a little bit of extra code, and so maybe we'll cover that in a future video. But for this one, let's just do public particle system. And we're going to do a new here so it doesn't complain at us about it already existing. And for this, we're literally just going to do particle system dot transform position equals position. We're just going to move it there. And this dot particle system dot emit 1. So if you do this, with a different system, this might not be kind of what you want. But usually the way I do particle systems is there's some sort of top level system, and that's just sort of the trigger. And emitting one of those triggers all the sub-emitters and everyone's happy. This may not work depending on how you do it. You may have to use something like .play. .play is fine. But I think emit is a little more accurate for like where you're actually trying to do things. Additionally, you can do emission params, and that would also work. So if you do emit, like one of the overloads here is this notion of an emission parameters. So you can set stuff like rotation or position or scale, that kind of stuff, and it works just fine. You can do this with some sort of overload method or an extension method to say emit at, and then you can just have this kind of handled for you by default. But for now, we're just going to do the overload that has a single particle, and we're just going to just call it a day. So we should have everything we kind of need for this to start working. So let's go back over to the project, and the impact prefab, we notice, is still here. So let's go ahead and change that now. So instead of an impact prefab that's a game object, we're going to do a particle event, which is the object we just made. We're going to say impact event now. And down here, we're going to swap this for impact event. And rather than this line here, in fact, let's just go ahead and comment this out and just do this a little bit differently. So we can see it basically the same kind of code. Impact event is not null. Then instead of doing this instantiation, we're going to do this .impact event .raise at first contact .point, right? And so there's no more instantiation. And note that the bullet actually has no say in what actually happens downstream as a result of the impact. It just says, hey, I hit something, I told you about it like I was supposed to, do whatever you want to do. But it doesn't control the particles. If you have screen shaker sound effects, none of that's here anymore. It's just some external system responsible for observing the impact event, which in this case is the particle event, and then it makes a determination of how much screen shake to use, what audio clip, that kind of stuff. And so all of that kind of feedback, user experience stuff is no longer involved in the bullet code. So note that just out of the gate, we get a lot of nice, architectural freebies from this, just because all of those specifics are no longer relevant to the bullet code itself, as they honestly shouldn't be. So let's go back out to here. Now what we need to do is actually make an instance of this particle event that we already had. So we said this was data/event/particle event. Let's say player bullet impact event. And let's go back over to our bullet prefab. So let's assign that here. And so now we need to sort of have instance of the impact here. So go ahead and create a new, let's just call this preloaded resources. Doesn't matter what you really call it. You don't even have to have a parent for this. And then impact listener, player bullet impact listener, particle event listener there. The event we're listening to needs to be assigned here, and then the particle system gets assigned here. I'm also going to unpack the prefab here so that I can remove this destruction behavior that it previously had. And then similarly for this one, because both of these would just destroy it by default, and I don't obviously want that. I'm going to up the maximum particles for each of these, because these were initially set to just like 10 and 20, which might not be enough for how we're doing things. But now I think we're basically done. So if we go back into play mode and I fire, note that it seems to work, right? So the bullets hit the wall, it plays the particle effect, And there's nothing else really involved. There's no, 50 extra particle systems being instantiated here. I don't have a pool of particle systems sitting here where there's 50 plus instances of basically the same particle system being played on loop. I just have a single system that's emitting in different locations. And again, personally, I think this is a much cleaner approach for this kind of problem. And again, the bullet doesn't need to know about a pool. The bullet doesn't have to relay its impact to the player, and the player makes that determination. The bullet just notifies an asset level object that it hit the wall and do whatever you need to do. And so I've always appreciated this kind of very clean approach to stuff, and I use it in a good number of my other projects. So in closing, similar to the last video, I would like to sort of show this same sort of topic in a more realistic project, outside of the kind of, clean room environment that you typically get in tutorials, and see, okay, what does this look like if I use it in, a project that intends to be around for at least a little amount of time. And so in this case, the example is going to be the current Quest 64 remake project that I've been working on for the last 2-ish years or now or so, where I'm using this notion of a scriptable object particle system, or particle event system, pretty extensively. Really just any notion of scriptable objects as an event base to relay things from one system to another. And so in this case, my spells are defined in this kind of graph approach, where all of the kind of core data, like damage, how do you actually travel, what's your collision masking, all of that kind of stuff is here. But curiously absent is any sort of visuals or audio or what if the screen shakes, that kind of stuff. And so those aren't handled here. Those are handled through this kind of scriptable object event, where an event is emitted once the impact occurs that has information like, what was the element, how much damage did it do, and then downstream that's kind of handled. And so in this case, I'm able to sort of go into my player. I have some sort of little debug thing here, and I can just play individual particle events on top of the player to see, okay, is this roughly the effect I want for this kind of system without needing to change code or any of the actual spell graph stuff in particular. So in this case, I can click on something like Wind Bomb, and it does have audio. And then I can just emit it kind of on top of the player. And what this lets me do is go to something like the Wind Bomb actual emission code here, or the inspector. And let's just look at how this is going to see if there's any differences from how we did it previously. And the only difference here is this notion of a particle unity event, which is an additional thing that's defined here, which basically allows me to have this kind of inspector shown, where I can add individual things here, and rather than editing code to say like I want to add an impulse event, I can just add a new impulse. And again, these are also defined as scriptable object events. Add a mid one, go to its particle event, note that this is a particle event verbatim, emit it, and now I have a screen shake. And so this kind of separation from, the core code and the core definition for how is the spell defined and what does it do when the spell actually comes out is very powerful. And you get a lot of these, again, architectural freebies, to reuse the term, just from having these asset level scriptable object relays from stuff like your core systems, and then downstream observing them and having some sort of audiovisual feedback in response to a core system. So I just wanted to show that for a second. If you want to sort of see how this kind of thing works for particle event listener, particle unity event, to do one of these, you need to override, you need to basically inherit from unity event for whatever the signature is for the particle event and then make it serializable. And then once you do that, you should have something that looks kind of like this. You can kind of drag and drop stuff in there as you will. Note that if your call signature is the same as what's being emitted for the arguments, then what is this using? Emission helper, emit it. Yeah, you get this very nice pop-up here at the top where the arguments from the event are passed into the function directly. And so you don't have to manually assign anything, because otherwise you can only assign one variable at a time. It's a little clunky. But if you don't have variables on there, like in this case, if you have a generic event that doesn't have variables, or in this case, particle event.raise is already here, so that plays nicely, then it's pretty seamless. And I really appreciate this kind of approach. And again, this project uses it for almost everything. Stuff like door audio, scene loading, dialogue, that kind of stuff. It's all very event-driven through scriptable objects. So if you hadn't seen this approach before, I hope it was at least a little bit educational. And again, wishing you all the best luck on your game to adventure. All right, bye all.